Hi, I'm James Fran. I worked with Kyle Lance and Alex McWilliams to develop a pneumatic can crusher. Over the course of the semester, our design group for a senior design project has been designing and fabricating a pneumatic soda can crusher. We chose pneumatic because there are several different options of cylinders and solenoids, making them efficient and relatively easy to use while also being fairly cheap. We could have gone with hydraulic, but that's much more expensive and a little harder to use. We had a few problems during this. We mostly came over those, except since the COVID-19 pandemic happened, we haven't been able to finish this project. The purpose of this project was to create a fully pneumatic can crusher using a Raspberry Pi, which is a form of small computer that you can use to program a bunch of different things. Now, a can crusher's purpose is to make cans smaller so you can recycle more at a time. The last can crusher developed by the engineering department was back probably around 8 years ago, but had problems with jamming. So we took it upon ourselves to design and fabricate a new and better can crusher. Our design and solution, the original sketch changed a little bit when we went to a 3D sketch, like the way the cans load and things like that. For example, another thing is we had to change the solenoids. We went from a 2-position 3-way to a 4-position 5-way solenoid due to it is easier to control and it allows for better control over the entire operation. We had to do some calculations for this. Mainly, we had to calculate the pressure required, which required a force and an area. Now, the diameter of the bore of our cylinders, the bore of a cylinder is the larger plate. Now, the diameter of the bore in this situation was 2.5 inches. When we plug it into the area equation, pi d squared over 4, we get an area of 4.91 inches squared, or in meters 0.03167736 meters squared. Now we plug that into the pressure equation, which is force over area. The theoretical force in this case, which is the required to crush the can, is 88.9 newtons, or around 20 pounds. Which, if you plug that into the pressure formula, you either get 28,064 pascals or 4 psi. However, in our situation, we're just using the full potential of our cylinders, which is 100 psi. Fabrication, first thing we did was we wrapped each fitting with red tape so there's no air leakage. Then we screwed each of the fittings into the cylinders and solenoids with a wrench, again, to make sure there's no air leakage. Then we cut the air tube to the proper length. If we didn't do this, we'd lose power because of the length, and there'd be loss of air. Then we cut wood and assembled the wood housings for the cylinders, the load mechanism, and the crushing plate that was then attached to the vertical crushing cylinder. Then we made a 3x3. We took a 3x3 foot piece of plywood and mounted the different parts, like the PVC loading pipe, to the plywood using metal tube clamps. Then we use leftover plywood to make a bottom part for the assembling of the soda can injector exhaust air tube, which pushes the can out using the exhaust air after the can has been crushed, making it safer so a person doesn't just get their hand caught in there trying to take it out. This picture on the right is what we ended up getting accomplished. We would have accomplished more if it had not been for the COVID-19 pandemic. We would have done some hypothetical testing. We would have done testing if this COVID-19 hadn't happened, and what we would have done, we would have loaded 10 cans into the feed tube, then measured how long it took to get through those cans, then calculated how much it would take for a minute, how many cans you get in a minute, then we would have calculated how many you get in an hour. which would have also helped us determine how much money you'd make an hour if you use this can crusher. Like, if you, it would cost like however so much if you took it to a recycling center. Then we would have tried to doing tests to determine the efficiency by plotting the original volume versus the final volume of 3 different can sizes, which ranged from 8 ounces, 12 ounces, and 16 ounces, and the cans, in our opinion, should have been around less than or equal to 30% of their original volume. Cost analysis, we had plywood, we had PVC pipe, pipe clamps, screws, pneumatic cylinders, pneumatic tubing, but in total that cost $376,000. Not $376,600, and I believe our overall budget was around $500, so we came in under budget, which is good. It's always good. But the 3 things that took up most of that were the pneumatic cylinders, the solenoid valves, and the Raspberry Pi. Outcome, due to COVID-19, we were not able to technically finish this due to if we weren't able to meet up to program the Raspberry Pi, which would have automated the system. However, we were still able to develop a machine that crushes cans semi-automatically. However, in this case, the operator has to control the solenoids using buttons that are built in on them. So that's one of the main things that came out of this. But in conclusion, although we are disappointed that we weren't able to finish, we still feel as though we have succeeded in some aspects. We've learned from this. We've learned how to use brainstorming ideas. Like, this wasn't technically our original idea, but this is what it ended up being. Then we had to use critical thinking whenever design flaws came into being, and we had to design and fabricate different aspects like the loader of the cans and all of that. But we feel confident in that if the semester had gone as planned, we would have met all of our goals, which would have been a fully automatic can crusher that would have been able to go fairly quickly and fairly safe while being fairly efficient. So, all in all, I believe we have had some major success with this project, and I don't feel bad about it. So that is all I have, and goodbye.